we're going to resume. So what we want to do is finish this page off so that we can populate it if our users clicked edit and we have an ID in the URL, and then add some conditional logic on our save button so we can do an add or an edit depending. Once we have that done, we'll have finished create, read, update, and delete functionality on students. Then I'll give you guys your lab. We'll probably get out of here a bit early today. Okay? I don't expect to get a whole lot of objection there. Okay, so let's open up, actually I'm just going to make a couple of small forms. I'm going to open up student.aspx. We don't really need to change much in the HTML. I'm just going to format stuff a little better. If I apply a bootstrap class onto these labels, they'll all be sized at the same width, which means our text boxes will align, and then I can move my save button underneath. Don't have to do it, but we might as well. So in my labels, I'm just going to give these all a class of, going to use call small 2. So Bootstrap uses a 12-column grid system. So if I make each of these two columns wide, they should get I should get a standard width, and now they should align. That looks better. The other thing I'm going to do is move my save button over here, so I'll use a similar class to offset. I'll put the button inside of a div tag, and I'll apply another Bootstrap class so the button will appear over here instead. Actually, we already have it inside of a div, so I'll give it a class of call SM. I think if I use offset 2, that should move it over 2 columns, so it'll align with the text boxes. That may not put it exactly where we want. We'll see. I think that should do the trick. Yep.
Right on.
Now, we don't really need to change anything else on the HTML of the page. We just need to change the C#. Right? Our interface is going to be the same regardless of whether we're adding or editing. We already have the fields we need. We've already set up the max length properties and all the validations already here. So again, this is one of the reasons why I prefer not to do the editing in the grid, because we already have the interface set up the way we need it. Excuse me. So now we should be able to go into our CS file. We're going to have to make changes on page load. We're also going to have to make changes when the user hits save. So the first thing we need to do is make sure that we can pre-populate our form if the user's clicked edit. So right now on page load, we have nothing being called. We're just loading the form. So I'm going to write a get student function. Which we'll want to call on page load, but we're not going to always want to call it on page load. Basically, we're going to want to invoke get student. So just so what two conditions, under what two conditions do we want to call get student? Right, so first of all, if it's not post back, right? We don't want to do this if the users click the save button. But we also have a second condition, right? Because if I just go to my students page and click add student, is post back is going to evaluate to false. do we want to call get student in this case when I click add? No, we're not looking anything up. So we also need to check, and we'll put the comment in. So if save wasn't clicked and we have a student ID in the URL. So we're not just going to have one condition here, we're going to have two. So what we need to do is check whether we have a student ID in the URL, yes or no.
Yeah.
Okay. There are a few different ways we can do this. The way we can access the query string property, Sam?
Is it request dot
Yep,
query string?
you got it. So what we can check is if the request dot, there's several different ways. We can check specifically for a key called supplier ID. This page is never going to have any other query string value. We could just evaluate the query string count. This will tell us how many keys were in the query string. So we'll just check it and say if the count's greater than 0. Okay. So there are several different ways you can do this. As I said, we could look specifically for a student ID value. I'm just going to check. So count will tell us how many key value pairs are in the query string being the part of the URL after the question mark, so any parameters. So if our form wasn't posted and we have a value in the query string, then we'll call get student. So what are we going to need to do here inside of get student to populate our form? How are we going to do it? Okay, we're going to have to grab the ID using the request object in the query string collection. So we're going to have to get that ID. That'll be step 1. Yep.
And then once we get that, we query the table.
Yep. So we'll use Entity Framework in our student model in a similar kind of manner that we did here, right? Basically, we've already written the code for finding a record based on the ID. So now we'll have a student object, and then we'll need to do one more thing. What else will we need to do once we have that student object populated from the Entity Framework? Not yet. We're not saving yet. Yeah, we're going to have to map each property of our student object to a control on the form. So basically the reverse of what we're doing here. Here, we're populating properties of the object from our form controls. We're going to have to go the opposite way. We're going to have all of the values in our object, and we're going to have to map those properties and place each value into a control on the form. So the first thing we'll do is we'll set up an integer variable called student ID, and we've got to pull it from request.queryString. It's a collection, so we can refer to that key either by index, so we could just use 0. I prefer to use the names. And it would also help if I actually use the right key name. That'd be a good idea.
Oh yeah.
Query string, by definition, it will always cast the value as a string, so we're going to have to convert it to an integer. So first we'll get the ID out of the URL, we'll cast it as an integer, we'll store it in a variable. So now we know which student record what ID we want to pass to Entity Framework. So now we'll connect I'll actually manage to get my bracket statement right with a using statement for once, probably the first and last time I managed to get that correct. So we'll connect to the database using any framework. So I'll create a variable called S of type student, and we'll write our link query. So we'll use our student model. We'll pass in our student ID variable. And we'll select first or default. So after this line of code runs, our S variable, student object, should be populated not only with the ID, but also the first name, last name, and enrollment date. So then we'll map the student properties to the form controls. Oftentimes what I actually do, if I write my save method first, I often just copy those lines from my save, put them in my get, and then I swap them. But I'll type it, so we'll populate the last name.text equals our S. So our S is a strongly typed object, right? It contains all of the properties of the student model.
Did you write that query or you just copied it?
I wrote it.
They didn't.
Thank you. And our enrollment date, we're going to have to convert to a string because enrollment date is of type date time. So you can actually pick to string, or you can pick I'm going to say to short date string, which will ignore the time. We do actually have the time in SQL Server, but we're ignoring it. If we look in our database, if I connect and query the raw data, because SQL Server doesn't have a separate date-only data type. It just has a date time. So if we look in our students table, actually, we didn't put the times in. That's good. I thought we did have them.
Yeah, we changed it.
We did change it. So this should populate our form now, if we compile. So I'll go back. I'm going to click on add to make sure we didn't break anything. So add still works. And now if I pick on student, our form's populated. That's because if Chrome doesn't like it, it's because you've used text mode date. So you can remove that property. We've got the range validator anyway that's checking for a date, so we don't really need that text mode on there. Good question. Try changing that just to, okay, actually let me load it in Chrome and play around. We'll play around with it. We're certainly going to have to cast it as a string, no matter what. Right, so the question is whether we can still get it to work in Chrome if we keep the HTML5 validation there.
Okay, let me take that.
Because it wants that format.
So you're having 50% of your daily saturated fat. How do you write this right now? Why would you not eat both? Ben, if you're looking for chocolate bars, I'm not
That is a fair question. We'll have to think about what to do in Chrome if you want to use that. Yeah. So now we can populate any record. If we pass in a student ID that it doesn't recognize, so we may want to do a little check here. We may want to make sure, because it's going to crash here if we don't have a value.
Oh, yeah. Would you see like a, oh.
So what we want to evaluate,
You want to check that last.
well, let's check what happens. I'll run it through the debugger. We'll evaluate what S looks like if we put in an invalid ID. And then we'll probably want to wrap this in an if statement just to make sure that we actually have a valid object in our S variable. So if I use 3000 as the ID, which doesn't exist, so S is null. So we should be checking whether S is or isn't null before we try and populate our form. So I'm going to add if we found a match.
from that same.
Actually, yeah, you know what, we can even check, I'm gonna run that again through the debugger. We could even check the student ID. I wanna see whether it's gonna be 0. So it should be nothing. Or the whole thing is null. Okay. We'll try it this way. I may need to massage this code a little bit. So if our student isn't null, then populate the form. I'm not sure this is the best way for us to check. But we will see if that'll give us the result we want. I think I'd have to start my server again.
They're probably the same page.
Yeah, so just checking to make sure that our student object isn't null will prevent it from crashing. We will look at full error handling with .NET later on. I think we'll do that. Basically, our sort of program after reading week is we'll look at using related data, working with multiple tables, and looking at how Entity Framework generates the associations between the models. That'll be our first class after reading week. That'll be lesson 8. Lesson 9 will be authentication. Lesson 10 will be exception handling. And then we've got a couple of other classes where we might get into playing around with MVC or Web API or maybe a little of both. So we're
Oh, sorry. Like WCF, is that like similar to this stuff too?
WCF is a slightly older version. They're basically of what now they're calling Web API. Okay. I would hope that we'll have a chance to play around for one class with Web API, which is here. Basically, originally it was called Web Services. Then they made it WCF, which was Windows Communication Foundation, and now they're using the term Web API, which are basically web services. So how to, for example, build a web service so another application can talk to ours and exchange data. Typically we use JSON as the data format. We use JavaScript, basically JavaScript arrays. So if you're interested in Web API, this is the place to go. Go to Learn, click on Web API. There's a whole host of tutorials here for how to build one. I'm hoping in week 12 we'll have a chance to play around and go through one of these tutorials and build out a simple Web API. What we could even do is use our Contoso database and build some API methods into it. So other applications could send data in or pull data out without any kind of user interface whatsoever. We'll look at doing that. And we can probably and we should be able to host those on Azure as well. So that's kind of where we're going. Okay, so we're almost done. What we have to do now, the problem is if I hit save, oh, good old Ralph. Loves our university so much he's enrolled twice. Okay, so we're going to have to make some changes here. Everything here can stay, but we're going to have to add some stuff. Right? So what will we need to do inside of save so that it can process not only an insert, but it could also process an update if we wanted to instead? So how are we going to know which one we're doing?
Check the URL.
Yeah, so we can check, again, we can check our query string. If we have the query string, we'll want to instantiate our student object using the student ID. And then we'll still fill the properties, but we're only going to call add if we don't have an ID, okay? Right? Otherwise, it's going to just add a new one again. So we're going to need 2 if statements here. We can still use this S variable here, that's fine. So we'll check the query string for an ID so we can determine, add, or update. So we'll put in an if here. We can use the same. So if our query string count is greater than 0, we can declare a student ID variable again. So our same line from up above, and grab the ID from the URL. Whoops, sorry, that has to be in double quotes. So we'll get the ID from the URL. And then we'll get the current student from the entity framework.
What method is this in?
This is inside of our save click. So when the user clicks save, before we go ahead and populate the student and call save, we need to check the URL, do we have an ID, yes or no? Because that's going to tell us whether we're adding or updating.
So what if the user was to just throw in a dummy query string?
Well, I guess technically, to make it a bit better, rather than just checking the count, we should be checking specifically. We could specifically check request.queryString student ID. That's a good point. So we could check, for example, I think there's a function is string or empty. We could use that instead. I think we can try it this way. So if not, oops, sorry. No. Okay. We'll try and check the length. We can try it this way. We may have to play around with it a bit and see if we can break that. So I'll check whether the length of that exists.
Sticky keys enabled. I hate that. And it'll say, would you like to disable this? You say yes. And then it's going to disable it.
So we've already created an S variable here, which is fine. So now we'll run our same link query. So this is, again, the same link query we're using above in our get. Whoops, that should be double equals. So we've used the same link query 3 times. Anytime we want to get that record. So that will populate our student object, but only if we have an ID.
Do you ever make methods with just those queries in them?
Sure, you know what, I suppose we could make this, let's run it this way,
Yeah.
and then, yeah, rather than repeating it twice, what we could do, we could make that a global variable on this page. We can declare it up at the top of our class, and then we could populate it. Yeah, that's probably a good idea. Rather than repeating that method twice, we don't need to, so we can make this code more efficient. That's a really good idea. So in either case, this stuff happens outside of the if. We're still going to populate the last name, first name, and enrollment date from our form, regardless of whether we have an ID or we don't. So this section in blue is going to happen anyway. This, however, again, is only going to happen if we don't have a student ID. In fact, I think what I'm going to do, rather than declaring my variable here, I'm going to declare it up here, and we'll initialize it to 0. Then I can get rid of the int32 there. Okay? So by default, student ID is 0, and if we find an ID in the URL, we'll change the student ID to be whatever number's in the URL. So now down here, before we decide whether we're adding or not, we can just evaluate our student ID, right? If it's 0, we want to call add. If it's not 0, we don't need to do anything. All our code will just run and our add won't fire. We just populate our properties and call save changes, and because we have an ID, it will automatically do an update. We don't have to call a specific update method. So we'll say if student ID is equal to 0, so we're going to call save changes no matter what. So this will run the update or insert. So the way that Entity Framework knows which one we're doing, if we're calling add, it's going to do an insert. If we call save changes without calling add, and where we've passed an ID number into, given our object an ID number.
So if you call save changes and you have an ID in your URL, we'll just do an update.
We'll do it automatically.
That's amazing.
So let's run it like this. Let's make sure it works, and then we'll tweak it so that we're not repeating this link query. We should be able just to put it in a function and just call the function instead. So we'll compile. And now I'm going to try adding a new record and then editing it. So we want to make sure we didn't break add. Okay, great. In just a second, I want you to tell you how you did it. So add a new record first, because let's ensure we haven't busted that. Ah, okay. Doesn't like this. We can't check the length property because that object doesn't actually exist. So our length property we can't evaluate on a non-existing object. Object reference set not to an instance of an object means we're trying to reference an object that isn't instantiated, doesn't exist. So that check,
Can you just check if it has a value or not?
it's not if it has a value, because it can exist without a value.
It does not equal null.
Yeah, we could say does not equal null. That should work. So if request.queryString student ID is not null, so that means that is an existing object. We'll try it that way. Well, yeah, we did check here, so we could check here as well. But you know what, it's okay, because if they put in an ID, it'll just run the where clause on a non-existent ID, and it will save an update with a where clause to a non-existent ID. So in effect, nothing will really happen. It will try and update a record that doesn't exist, right? If you say update students, set first name equals Tyler, where ID equals 5 million, that query will execute, but no data will be affected by it. That doesn't generate an error.
I've checked the data there too. Can you also do injection?
No, you can't do injection because our student object is strongly typed,
Yes.
right? It'll throw an error if we pass in anything other than an integer as that value. Now, we could check here, so this line will crash, right? It's trying to convert that to an integer right here. And then we're passing that into our object, which is a strongly typed object. So we basically are protected against injection. There. So we'll try it one more time. So now I was able to add. So we can just check, instead of checking the count, we'll just check if our student ID is not null. Now we have to see whether update actually works. We know we can still add, but we have that code working 7 days ago. So can we actually edit? So notice it'll save all the fields, even without calling update. Entity Framework's smart enough to know if there's an ID and we call save changes and we didn't call add, that it will update that record. So I'll delete that one. Go ahead and edit one. Okay.
Change the ID in the URL to something that doesn't exist. Change like 3,000.
Okay.
And then hit enter. I don't think it refreshed on the
Because on the post back, it'll put the URL back. It will automatically remember the URL, so even if you change it, that won't persist on post back. Okay, because, and here's why, Ben. It's a very good question. If we view the source, right, here's the action. So even if I change that, the form tag is still rendered with that original URL. Okay, so it just it'll ignore it. And Tyler, we can try what you suggested. So for example, if I change that to say, drop table, departments, right? We're going to catch that. So it's never going to run if we try something like that. That's one of the benefits of Entity Framework, is that all of our models are strongly typed. Syed, did you want to tell us how'd you do the date?
Oh, just go to the .2 string.
Sorry?
Wherever you do the .2 string for the date.
Yep.
You can change that to two string, and then you have to put in a date format.
Okay, so you put in 2 string and you matched.
Yeah. Matching it year on a day.
So it's in double quotes, I think. So like that? So that would be your workaround for Chrome, for HTML5. Let's try that in Chrome. Yeah. Okay, thanks. Good fix. Thank you for that. So we can supply the date format. That's what Chrome wants if we're using the data type of date. Chrome will display it this way. So what we could do, we have some repetitive code here in our get and in our save. We could probably streamline this and make this a little more efficient. So we've declared a student here. We've got an integer for student ID. So we could move these variables up to the top and then put our link query into a function if we wanted to. Do we want to? I don't know. I'm happy with it this way. If you wanted to change it, all you'd have to do is move these 2 up to the top inside of our class, but before page load. So now these will be global within the page. So then we don't need to declare those, and we could just move this to a function.
So it would be like a function that returns.
We don't. It doesn't even have to return it because student is global, so we can just populate the S variable in our function, and then it's available in others. So we could write protected. We could make it void, really. We don't have to return anything. So we'll call it fill student from EF. And just paste it in. Except now we'll need our connection inside it as well. So you'd need I'm going to roll all this back, but this is how you would do it. It was new. So then we could just call the function here. We could just call, fill.
But could you only call that in the student ASPX.cs? What about other?
That's right. It's not available. You could put it in a class. So we could create another class, a public class, and fill it that way. Then we would want to return it, though. Then we would need to return a student object. So it would have to be protected, student, and then you'd have to return S. So you could do it that way. I'm going to undo those changes, but if you wanted to make it modular, that would be how you would do it.
Yeah, if you got big programs.
Yep. So you could certainly do that. That's one of the limits of Entity Framework for building your own model, is that it generates your own models. You can't write your own custom functions in those models. That's the benefit of code first, right? If you do code first, you can create those things in your models, generate the database from there, and then you have those functions. But you could create your own helper class, right? So you could create a student helper class that would have those kinds of reusable functions that are available.
How do we get data joining?
How do we do joins? We're actually going to do that in 2 weeks, okay? So we've got the students, basically we have create, read, update, and delete working for students, okay? For your lab, which I'm going to give you in a minute, you're basically going to build, create, read, update, and delete functionality for the departments section, okay? So you're going to build out the departments plural page and the department singular page with add edit. Courses, there's a relationship. If I open up the model, so if I open up my EDMX file, so there is a relationship in the database, or in EF model speak, there's an association. So every course belongs to a department, so we've got one-to-many. So that's what we'll do our next class after reading week, is we'll build out the course section. So we'll look at how on our course page do we generate a drop-down of the departments using Entity Framework, and then how do we save that, right? And then on our departments page, we should also be able to pull up a department and see a list of the related courses as well, right? So that's what we're going to do in a couple weeks. So let me give you your lab. So your lab's due tomorrow night. So basically, you don't have to create a new solution. Just take what you've done in class today, okay? And you can add on. So you basically have to build 2 pages. Build departments.aspx, which has a grid view that shows the list of departments and has edit and delete functionality in the JavaScript confirmation. Okay, there should be a link to add and a link for editing that will go to a page called department, where we can add a new record, and the department ID would be auto-generated by SQL Server, or edit an existing record. Okay, so basically the Monday class, for the Monday class, in class on Monday, we built departments, and their lab was to build the student pages you guys did today. And yeah. So basically, here's what you're building, right? We'll need the grid. See if you can figure out how to format the budget as currency. In the grid, there will be 4 departments. The first 4, English, Math, Engineering, Economics, are from the script. Those will auto-populate from the script I gave you. So if we put in test, and we can save, I can edit, and then I can delete. So that's the lab. So just chance for you to practice on your own the stuff we did together.
Basically just replicate.
Yeah, so you're replicating. You will have to figure out the currency here, how to see if you can format that. But it's a chance for you to try the create, read, update, and delete again with Entity Framework on your own. Okay, so the lab's due tomorrow night. Take your current solution that you have from today. If you don't have it from today, you can add it. You can work with the lesson 5 solution from last week and build out basically 2 pages, departments and department singular. So all I need is the Git link and the Azure link to your page. Okay, so 2 pages due by tomorrow night. Okay, so when we come back, so next week is the midterm, 2 weeks is reading week, and then in 3 weeks when we come back, we'll do the courses, create, read, update, and delete, so we can see how the data relations work with Entity Framework. We can do one now if you have specific questions.
I mean, just like you gonna post something that we should be touching up on, or is it just gonna be based on the stuff we've done in class?
Just going to be based on what we've done in class, right? So some basics about ASP.NET, setting up projects in Visual Studio, how .NET works, you know, that our code is compiled.
How big is the code section we did?
It's not that large.
Small programs?
Is it all practical?
No, part question and answer, part practical, but it's open book. Open book. Okay. And then we'll just keep working with this and building this out. So we'll do related data in class 8, security in class 9, error handling in class 10, and then hopefully MVC web API. And then your second last class will be your application presentations, final exam. You guys are done. Okay, so I will put the